Hello guys, good evening. This is Pooja here, and today we'll talk about a very interesting topic, understanding lenses. Okay, if you attended my last lecture, which was yesterday, there we talked about mirrors, concave like spherical mirrors. Okay, so in today's lecture, I'll be talking about how about lenses. So as we have talked about mirrors, how are they different from lenses, or how are lenses different from
Okay,
mirrors?
if you attended my last lecture,
Just
which
a
was
second.
yesterday,
I'm sorry about that. So, okay, so we have Samriddhi here. Hello, Samriddhi, how are you? Hope you're doing great. And before we get into the details, a little bit about myself. So, I don't know why is it not displaying. Just a second. It's not displaying the lecture. Give me a second, guys. Okay. Can you see it now? It's all darked out. Hold on, let me redo it one more time. Okay. Can you see it now? That's okay. I'm just asking, is it, are these slides visible to you? Because I cannot see the slides on my display thing. Can you see the slides, Smriti? Okay. So display capture is on. Somehow I'm not able to see the slides. I'm not sure whether you are able to see it or not. Let me check. Let me double check it. Are these slides visible to you? Yep. There's some issue here. Let me redo it again. So there were some issues with this. Are you able to see the slides now? Guys, I guess there is some issue with the slides. Okay, let me fix it. I don't know what's going on. Yes. Okay, so it is visible now. I'm sorry about that. So there was some issues with the system. So anyways, I fixed it. So guys, today we will talk about all about lenses. So if you watched my yesterday's lecture, I talked about all the convex and concave mirrors, so spherical mirrors in short. So today we will talk about lenses, understanding lenses. What are the different type of lenses and what kind of different images are formed in the lenses. So if you remember, before we get into the details, let's have a quick introduction about me. So my name is Dr. Pooja and I was a scientist in the United States for 8 years. And today you can also watch a special class on Unacademy's platform where I'm going to talk about how to become a scientist, because as I worked as a scientist for 8 years in the United States, I have put together a very nice presentation for all of you if you want to learn like how to become a scientist, how to choose science as a career. Okay, so my educational qualification, many people are interested in that. I am PhD in biotechnology and I have a total 8 years of experience as a scientist and lab director in the United States. Okay, so currently what I'm doing is I'm an online fitness coach and I teach you guys science on Unacademy's platform. So anyways, if you are interested in signing up, here is my referral code, which is PS13, and you can sign up for the batch courses or plus courses on Unacademy's platform. So why batch courses or why Unacademy? Here is the reason. Okay, so we are India's largest learning platform, so where we teach you guys all the subjects, okay, not just science, not just English, all the subjects that you have. And for that we have best educators. We have got best educators from all over India and we take live sessions with you guys. Okay, so it is not just the live sessions that we take, we do have live practice question answer sessions and live quizzes and doubt clearing sessions. So with this we make the best online platform, because we not only finish your syllabus, we help you cover all these like issues or problems or troubles that you face while solving the numerical issues and other things. Okay, so here are the major highlights of or major features of signing up on our platform. So what are those? First of all, you don't have to go anywhere. From the comfort of your house you can sign up and you can watch classes that we take, and there is unlimited access to that, which means you really don't have to, like, let's say you miss some lectures, so those lectures are saved for you, so anytime you can go back and watch those lectures. And like I personally teach you guys physics, chemistry and biology on Unacademy, so there are many other educators on our team which take care of your other subjects like mathematics, Hindi, English, and other subjects, whatever you have. Okay, so we not only finish your syllabus, so here is the exhaustive coverage of the syllabus. We just not only finish your syllabus, but we do regular doubt clearing sessions, live test series, and study material is always available for you in the form of PDF. Then question answer writing sessions are there. So these are the different points which you must consider before signing up. And how are batch courses different? Because in the batch courses we give you training for all the subjects, not just one subject that you have. Whatever you have, we create the batches, so which means you are studying from your home and everything is covered. All right, so there are different options that hello Mr. Patel, how are you? So there are different options like how to sign up on Unacademy's platform. So these are the options that you can opt for. You can go to the website of unacademy.com. There you can sign up for 1 month, 3 months, 6 months, 12 months. Now we have updated plans as well, and you can find those on the website itself. Okay, and you can also download the app for them, and you can always get benefit of signing up for the batch courses. All right, so here is today's topic then. So before we get into the details of what are different type of lenses, first we will have to talk about what is light, what is reflection, and what is refraction. So if you understand these points, then it will be very easy for you guys to understand this point. Okay, what are lenses? So let's hit it. Let's go ahead and talk about it. First of all, what is light? We know that light is something which helps us in seeing other objects. It travels in straight path, and all those things. And when we talk about the mirrors, we talk about reflection. Okay, so what is reflection? As I discussed before, when a light hits a surface of the mirror, okay, the other surface is polished. When it hits the surface of the mirror, it gets reflected. Okay, so that if you are interested in knowing more about that, like how reflection happens in spherical mirrors, how are the images formed by the spherical mirrors, then you will have to go back and watch my previous video. Okay, in today's video we will talk about refraction. Okay, so here is the point to understand. When we have a one surface polished, okay, then we have reflection. That physical process occurs, which is called reflection. And when, let's say, the other surface is not polished, but the lenses are having different density as compared to the air where the light is really traveling, okay, that is called refraction. We will get into more details of refraction here. And so reflection is somehow related to the spherical mirrors, and refraction is somehow related to the lenses. So let's keep that point in mind, and let's start our journey of understanding what lenses are. Okay, so here we go. So what is refraction of light? So that is the main point that you have to understand before even we start talking about the lenses. Okay, so let's see. While traveling obliquely from one medium to another, the direction of propagation of light in the second medium, it changes. Why? Because of the density difference in the medium. I will show you in a picture in a minute. Okay, so if you have ever noticed, like when you dip a pencil in water, so do you see it looks like the pencil is at a different angle? Or if you try to read letters with a thick glass slab, then you will also be able to see the words are little elevated. Okay, and third is like when at the bottom of the water tank, if there is a small stone, it will look to you like it is little displaced. It is at a different position if you try to hold it. So why all these things are happening? So this is because of this phenomena that we call refraction of light. Okay, so refraction is basically when the light is traveling from one medium to another medium, and there is a difference in the density of the medium. Okay, that is called refraction, and here is the example that I just talked about. So you see this pencil, we have this pencil dipped in water at an oblique, at an angle, and you see it looks like there is another pencil over here, right? Similarly, with this wooden log, it is dipped in water and it looks like there is another wooden log. So why is this happening? Because the density of the air, which is like over here, is different from the density of water. Water is denser than the air. So when the light is getting through this water to the air and then to our eyes, it changes its path, okay, which is called refraction. It is at an angle now, okay. So that is the whole point when we talk about refraction of light in case of lenses, okay, because lenses, they are made up of thick glass, and we'll also talk about what are different kind of lenses out there. We have convex lenses, we have concave lenses, basically biconvex and biconcave, okay. I will show those diagrams, I will show those pictures. Hello Nishant, how are you? In a minute. All right, so let's see. So refraction, when we talk about refraction by spherical lenses, so we know that lenses, they have two surfaces. So one could be spherical, the convex lenses and concave lenses. Here are the examples. Okay, so these type of lenses. Okay, Kanika, hello. So these type of lenses are called converging lenses, and these type of lens are called diverging lens. So what is the difference between converging lens and diverging lens? So first of all, this converging lens or biconvex. See, you have in my previous video, I've talked about what is convex. When the reflecting surface is little bulged out like this. Let's consider there is a big ball, okay, spherical sphere, and we cut it into half, and whatever we see is the this refracting surface in case of lens, okay. And biconvex lens, because both the surfaces are convex. So bi means two, convex means whatever its shape is, it's bulged out from both the sides, okay. Then we have concave lens. You know, if I show you only this part, only this much, this is concave. But because it is having two sides like curved inside, so this is called biconcave, because bi means two. The two sides are curved inside. So why are the biconvex lenses called converging lenses? And why are biconcave lenses called diverging lens? We'll talk about that in a minute, okay. First of all, just have this thing in mind. What are biconvex lens and what are biconcave lens? Here you go. So this diagram shows why the convex lens. So I will just say biconvex lens as convex lens. If I say convex lens, just understand I'm talking about biconvex lens, okay, which is convex from both the sides, just like this, okay. So we have this biconvex lens and it is called converging lens. What is converging? Means when the light hits the lens, you see, when the light hits the lens and when it is coming, this is the light which is incidenting on the lens itself, and this is refracting after passing through the lens, because the material which makes up the lens is thicker than air. So when light passes from one medium to another, it changes its path a little bit, and that is what we call refraction. Okay, this is what is happening in this biconvex lens. Light is entering. You see these blue lines pointing towards the lens are incident rays. and after passing through the lens, they are coming out and they're meeting at this point. When they are all meeting at one point, that is called convergence. Okay, they are all meeting at this point. You see F2 point, this is what we call convergence or converging lens. So biconvex lens are converging lens. So let's go to another example where we have this biconcave lens. See, both the surfaces are curved. So this is the example of biconcave lens. Bi means two. It has two concave surfaces. So these type of lens, we call them diverging lens. Okay, why diverging? See, these are the incident rays. These blue arrows in the direction of the lens are the incident rays. Okay, and after they hit the lens, they get refracted, and when they get refracted, they change their direction and they are moving away from each other. See, this is going in this direction, this is going in this direction, and this is going straight through the O point. Okay, optical center, which is what we call it. So this is called diverging because they are not meeting at a one point. They are going away from each other. Do you see all these rays? They are going away from each other. So this type of a behavior of a lens is called diverging, or these kind of lens are called diverging lens. Okay, so convex lens are converging lens and concave lens are diverging lens. All right, so let's move on to our next topic where we say what are the important terms. Now we know what are the biconvex lens and what are biconcave lens, but our next topic is what are the important terms that we use when we have these convex or concave lens. All right, so look at this diagram. Forget about all these rays. We have already discussed those. So if we have this biconvex lens, okay, so you see, if you try to see, it is kind of, let's say there were let's assume there were two circles, one over here making this as a circle and one was this one. Okay, so that means if they are, we assume like they are part of two spherical or two spheres, so that means it will have two center of curvature as well, right? Because two spheres were there, we cut them and we took only one surface, which is, let's say, the surface of incidence. Okay, and that is why they have two center of curvature, which we denote by C. There are two of them. One is over here, we call it C2, and that is for this side, and one is over here, we call it C1, and that is of this part. Okay, so this is called center of curvature, the center, the imaginary center of the sphere of which the convex lens forms a part is called center of curvature. So in the convex, spherical or biconvex lens, we have two center of curvature. Then what is principal axis? So principal axis, we know that the imaginary line which is passing through the optical center is called principal axis, and it is the straight line. There is only one principal axis present in convex or concave lens. Third is what we call optical center. So here this point is the optical center. So optical center is the point of the lens where the light does not get refracted. It just passes through the straight path. It does not get refracted. Okay. So this point is called O point, which is optical center of the lens. Then we have principal focus, which are there are two principal focus on each side. We call them f1 and 2f1. This one is typically the principal focus, and here is the principal focus f2 for this side. Okay, so these are the important terms which you have to keep in mind if we are talking about lens. Here you go. So the next important topic is, what are the different type of images formed in case of convex lens or concave lens. So as I said in my yesterday's class, I talked about all about the mirrors, spherical mirrors, okay, concave mirrors and convex mirrors. And in today's lecture we are talking about lens. So if you watch that lecture, then the concave mirror and convex lens, they are going to give you the similar picture. Okay, they are going to give you whatever the convex lens will give you, the kind of images that we have discussed in case of concave mirror, and concave lens will give us the kind of images given by convex mirror. Okay, so this is all about like lens and what is the relationship between the lens and the mirrors. Okay, so if we go over this, and the images which are formed by convex lens, we get 6 different type of images. Okay, and the type of images that we get, it depends upon position of the object. Okay, and this is the table that is given in your NCERT book, and I have picked it from there only. So if you have a closer look at the table, it says position of the object, where the object is positioned in front of that convex lens. Position of the image, depending upon what is the position of the object, we get the position of the image. Okay, and that varies depending upon position of the object. Then what is the size of the image which is formed, that also depends upon the position of the object and position of the image that we get. And then what is the nature of the image, that again depends upon position of the object. So position of the object is very important point when it comes to the image formation. So the position of the object, it gives you whether it is at infinity, at 2f1, between f1 and 2f1, at focus like f1, between focus f1 and optical center. So these are the 6 different conditions that we have here, and depending upon these conditions, we'll have different positions of the images, size of the images, and the nature of the images. Similarly, for concave lens, we have only 2 conditions, and those conditions are whether it is at infinity or whether it is at an infinite point. So depending upon the position of the object, we'll get position of the image, size of the image, and the nature of the image. So now we'll discuss all these points one by one. Okay, guys? So before even we talk about it, like how the images are formed, before even we talk about the type of images, the location of the object on the principal axis, the other important point that we need to consider is what are the different kind of incident rays and refracted rays that we get. So once we understand that, then only we will be able to talk more about the type of images which are formed here. Okay, so let's say there will be different type of rays coming and going from the lenses. So what are those? If the ray of light of the object is parallel to the principal axis. So this is our principal axis, guys, over here. This is our principal axis, okay? So if the ray of light, it comes parallel to the principal axis, after refraction, it will pass through the principal focus. You see, it is passing through the principal focus. Similarly, if we talk about concave lens, what is happening here? Principal axis parallel to the principal axis, it gets refracted, and if we extrapolate it, it will pass through the, you see this focal point, principal focus. Okay, so this is yes, so this is the example of type 1 ray which pass through the lens. Here is, let's say if the ray it is passing through the focus point, the principal focus, then after refraction it will go parallel to the principal axis. Do you see? It is entering from the principal focus F1. Do you see that? And after refraction it is going straight. It is going straight to the principal axis, parallel to the principal axis. Similarly, well, this is what is happening in case of concave lens. Light is coming, let's say it is from the focal, we have to extrapolate it, we just have to imagine it. Hello, Muskan, how are you? Right? So we have to assume light is passing through the principal focus, and when we see it is after refraction, it is going parallel to the principal focus, principal axis. Here, if the light is passing through O, which is the optical center, so after refraction also it will be going in that direction only. It will not get refracted, it will not change its direction or anything. That is, you have to remember that at the optical center of the lens. In case of both, see, in case of both convex lens and concave lens, it will still pass through the center. Then we have the most important topic for today's discussion, how the images are formed. Okay, so that is very important, guys, how the images are formed. So before we get into the detail of how the images are formed in case of convex lens, so let's first understand, have you ever done this activity? I would recommend you to do this activity. Take this convex lens, okay, take this convex lens and let the light come from the sun. Okay, let the light come from the sun and try to focus it on. Take another piece of black, let's say dark black sheet of paper, and let's focus the light coming out from the lens on that sheet of paper. Okay, and when that is happening, what will happen? This point will have very intense, rays gathering at a point, because it is a convex lens is a converging lens. It is gathering all the light rays at one point. Do you see here at F2? All the light rays are gathering at this point. And when they are gathering at this point, when they are focusing at this point, what will happen? What will happen? This part will start burning. Okay, so this is what happens when it is a convex lens. It is a converging lens. So let's first understand case 1, when the object is at infinity. So my first column is when the position of the object, second column is where the image is formed, third column is what is the size of the image which is formed, and fourth column is what is the nature of the image which is formed. Okay, so let's go over these points one by one. And guys, the most important point from this particular chapter is you will have to draw the diagram. So give me a second, I'll have a quick sip of my water. Okay, so what we see here, so in first case we will see the light is coming or the object is placed at infinity. When it is placed at infinity, light is coming from infinity. It is converging and the image is formed where? The image is formed at point F2. Over here is the point F2, right? And the image is very, very, very small. It is highly diminished. Highly diminished means it is a point-sized image. If you try to see sun, if you try to converge or focus sun rays, it will be very small. You won't be able to see sun. It is like, as compared to sun, it is like too small. Okay, and it is, the image formed is real and inverted. Okay, so that is our case number 1. Case number 2. So the case number 2 is, first one was infinity, the rays are coming from infinity. This is our case number 2, where the light rays or the object is placed beyond F1. So this is our 2F1, beyond 2F1 is our object. Okay, over here. So when this is the ray which is passing through optical center, that is what you will draw. And second, this is the ray which is parallel to the principal axis. After refraction, that we have learned in the previous slides, after refraction this will pass through principal focus, again F2. Okay, so where they both are meeting, hey, this is the point, A dash is the point where both the converging rays are meeting, and this is where the image is formed. Okay, so the image is formed between F2 and 2F2. You see these 2 points, F2 and 2F2. Here is the image formed, and the image size is very small as compared to the original one. And what is the nature of this image? So the nature of this image, it is real and inverted. So you will see all the images which are formed in the biconvex lens, they are all going to be inverted images. Okay, so this is what we did when we were talking about concave mirror. Concave mirror and convex lens, they are kind of same. They give us the same results. After this lecture, what you can do is you can compare the image formation by biconvex lens and concave mirror, and you will see lot of similarity. You will see they both look same. All right, so that way you will be able to remember them when you have this chapter to be prepared for your examination point of view. Okay, so with this we covered this point number 2, where we are saying like when the object is placed beyond this focus point. Okay, and guys, you see this is that f, small f is the focal point. Okay, this is the focal length and f2 is the principal focus. So the distance between the optical center and its principal focus is called focal point or focal length. I'm sorry. So now we will go over to the case number 3. So in case number 3, what we have is when the images, or I'm sorry, when the object is at the focal point, like F1 we have it. So you see this is also its center of curvature. So when we have the object at this principal focus, and see these are the 2 rays that we are considering. What 2 rays are we having here? The one passing through the optical center and another one is which is parallel to the principal axis. After refraction, it passes through the principal focus, and the image formed is inverted image. And where is this image formed? This image is formed at 2F2. You see 2F2. So this is what you need to draw when you get this question in your exam. And there is definitely a question from this chapter like where the image is formed if the object is placed at, let's say, f1 or beyond f1 or from infinity. So you have to memorize that table that I showed you. Very good evening, Lavesh. How are you? Okay, so this is the quick example of that third option that we have here. Now, guys, just to tell you who have just joined, my name is Pooja, and I teach you guys science on Unacademy's platform. Okay, and I teach physics, chemistry, and biology to 9th and 10th classes. Are you a plus student, Lavesh? So I teach you guys science, physics, chemistry, and biology. So this month is our physics month. We are talking about physics. We are talking about physics. We are doing all the numericals. We are doing revision for physics chapters. And an exciting news for you is next month is going to be our chemistry month, and after that the other next month would be our biology month. So in August you will be in July we are all talking about physics. In August we will talk about chemistry only, and in September we'll talk about biology. So in these 3 months you will be able to get a big picture of all the 3 parts of your science book: physics, chemistry, and biology. Okay, so if you have not enrolled for our batch courses, go ahead and do that, because that will give you a real benefit of signing up with us. Okay, here you go. So this is another case when the object is at principal focus, principal focus f1. We place the object here at f1. What will happen now? So you see there are 2 rays. So in case of these lens will take 2 rays, one passing through the optical center and the another one parallel to the principal axis, and then after refraction it will pass through the principal focus. Okay, so here you see, so one ray is passing through optical center and the another ray is parallel to the principal axis and then getting refracted. So what is happening in this case is, at focus, when we have the object at a focus f1 at infinity, you're not even able to see it, you're not even able to locate the image, and then we say because it is highly enlarged. Okay, and the type of image formed in biconvex lenses, most of the 5 out of 6 cases the images are real and inverted, similarly as we used to see in concave mirror. Then see this one. Lovelace, there is no lag. Is there a lag there? If yes, then what you can do is you can always go ahead and refresh your system. It is like too big as compared to the object over here, right? And it is formed on the same side of the lens where the object is. So in previous, you see these slides, the image is formed on the opposite side, on the other side after refraction. In this case at infinity, but on the opposite side. And in this case, in the third case, in the last case, when the object is placed between the principal focus and optical center, the image is formed on the same side. See, on the same side where the object is placed, and the image is very much enlarged and it is virtual and erect. Okay, so this is what we get when we have objects placed at different locations on a like principal axis for this convex lens. All right, so now we will talk about, in this case, now we will talk about how the images are formed when we do on a concave lens. Okay, so first of all, let's understand how a concave lens looks like, what a concave lens looks like. So just we had the biconvex lens. Concave lens has two surfaces like just like this, and they are curved inwards. You see, they are curved inwards. So the concave surface, that means it is coming from, again it is as we had those convex lens, okay, as we have those biconvex lens. Biconcave lens are also have their origin from, let's say, two spherical structures. And let's assume one sphere is over here and other sphere was over here somewhere. Okay, so now what is happening? We clubbed the two refracting surface together, and this is what is formed. It gives us a biconcave lens shape, okay, or shape or biconcave lens. So in this case also, similarly, we have the same terminology. We have this optical center, we have this principal focus, and somewhere here we will have the center of curvature. Okay, these terms, why I am saying these terms again and again is because when you listen to these terms again and again, you tend to remember them. Okay, and in case of this lens and in case of these mirrors, it is very important for us to remember the terms that we are using. All right, so as we have this concave, biconcave mirror, I would say, so this is the optical center as we have originally, is the principal focus. Here will be their center of curvature, and this line, this straight line passing through the optical center is called, yes, it is called what? Principal axis. This is called principal axis, guys. All right, so now what is happening here? See, these are the incident rays. The blue rays going in the direction of the lens are incident rays, and after passing through this concave lens, so again this concave lens is what? This is made up of glass. It is of thick material. So when the light rays will pass through it, they will change their path. Now if you observe it closely, we have this light incidenting. It is changing its path in this direction. When this light is incidenting, it is changing its direction in this way. Okay, so when it is doing this, when it is changing its direction, but have you observed one thing here? The light ray which is passing through the origin, you see, which is passing through the optic center, this, it is not changing its path. So you have to remember this. When the light rays, they pass through optical center, they are unaffected. Okay, they do not refract, they do not deviate, they just pass on straight from the, yes, this is kind of principal axis, they pass on straight. So now let's so this was that. And yes, another thing is you have to remember that the concave lens are diverging lens. See, the rays are diverging. Diverging means they are not meeting at one point. They're not meeting at this point, as the in case of biconvex lenses they were meeting at one point. In concave lens, they are just diverging. So we call them concave lens, we call them, they are divergent lens. And when we try to extrapolate it on the back side, they are meet at one point, which is the principal focus. This is the F1 point, principal focus. All right, so let's talk about this diagram, this ray diagram, and please guys pay more attention to the ray diagrams because they are very important. Okay, so the light rays are incidenting on the concave or the biconcave lens. They are diverging, And when we extrapolate, here is, because it is passing through the center and it is not at an angle, okay, it is, we say that the refraction occurs when the light ray, it enters at an angle, okay, obliquely, and this one is not at an angle, it is going straight through the center of the optical center of the lens, okay, so there will not be any diversion, it will pass straight through the lens, okay. So when the light rays are coming from infinity, when the object is placed at infinity, if we extrapolate them, these at this point, they all meet at f1, so they meet at focus f1, and again the image is going to be very small, it is a point size image, okay. And this time, in case of concave lens, the images that are formed are virtual and erect. Why virtual? Because they are here, they are forming at the, we are not getting the image actually, we are just trying to extrapolate the image, okay. So let's see the point number 2. When we have, so there are only 2 options in case of concave lens, okay, because all other points are on the other side of the lens. So let's say we have between infinity and optical center. The first case was anywhere from infinity the rays were coming, but in this case the rays are coming from point infinity, anywhere between infinity to optical center. Now we have optical center is here, and this is the object that we have. So now let's say we have 2 rays passing, one is parallel to the principal axis, it will refract, the other one is at the optical center and it will not refract, it's just passing through it, right, and this is the principal axis. Again, if we try to extrapolate it at the back, you see, so this is where the image is formed. So the image is formed in case of biconcave lens when we have the object between infinity and the optical center, then the, I'm sorry, so then this, the image is formed, is the diminished image is formed, okay. So and we see the kind of images formed in virtual and erect. So use of these lenses. So first of all, the biconvex lens, we use biconvex lens mostly in the magnifying glass that we have, that is biconvex lens, and the other uses of these lens are in case of your spectacles, okay. So when people, they have eye defects, when they have myopia and let's say nearsightedness or hypermetropia or farsightedness, so to correct those issues, what do we do? Like in hypermetropia, this case is we use this, and then they change the point where the image is formed. They either diverge it a little bit or they converge it a little bit, okay. So that is the uses of these 2 lenses, concave lenses or convex lenses. They are mostly used in the spectacles to fix the eye defects, all right. So this was all about when we talk about biconcave lens or biconvex lens. So from this chapter, the take home message is, what you have to learn is, what are the lenses, first of all, what are the biconcave and biconvex lens, what are the terminology that we use for these lens. Third important is, what are the different kind of rays which are incidenting and refracting, and at what angle they are doing so. And next important is what are the different type of images formed. And as I have just explained, the image formed in case of biconvex lens and biconcave lens, they depend upon, yes, Lavish, there are only two cases in case of biconcave lens. If you go back and study also the convex mirror and concave mirror, so concave mirror is equivalent to biconvex lens, okay, and convex mirror is equivalent to biconcave lens. That is very important. So go ahead and double check that. That will give you more clarity on the topic. Okay, so this is what you have to take away from this chapter, like what are the different type of images formed, what is the location where the image is formed, what is the nature of the image is formed when the object is placed at different positions on the principal axis. Okay guys, so with this we end today's session. And again, my name is Dr. Pooja Sharma and I teach you guys science on Unacademy's platform. If you are not following me, go ahead and follow me there and you will find tons of information. I teach you guys, as I said, chemistry, physics and biology. We have covered chemistry, we have covered biology, and now this month we are covering physics. How many cases? There are 6 cases in case of biconvex lens. So this month we are covering physics, and next month I'm launching a special course for chemistry. So my students, they requested me to cover chemistry, so I'll be doing that next month. And if you want to sign up for the batch courses, go ahead and do that and look for my code, which is PS13. I'll be sharing that at the end over here in the chat. Go ahead and use this referral code on Unacademy's platform, okay, and you will get 10% discount on this. All right, so with that said, I end today's session. You guys have a wonderful time. And yes, today we have a special class on Unacademy at 8:45 p.m. and in that class we will discuss about how you can become a scientist or how you can use science as a career.